Okay, welcome to 1.1, example 2. Here we're going to look at another transformation, and really all that's happened between now and example 1 is the function has become a little more complex. And in this particular question, it wants us to sketch the graph of y equals the absolute value of x minus 4 plus 3. Now, one of the hassles in transformations is that we really have to be able to identify what the original function was. And for this question, without any addition and subtraction, this would be as simple as f of x is equal to the absolute value of x. So I'm going to draw that first because knowing what the original function looks like becomes very, very important. For some of you math 20s, absolute value functions might be a little bit new. I'll write this out that the absolute value of x is actually two different functions. It is just x when x is greater than or equal to 0, but it is negative x when x is less than 0. And that's really to deal with the fact with how the absolute value behaves if we're applying it to a positive number or a negative number. So what that absolute value function looks like, and I think I'll do this guy in red, is it is just a linear line with a slope of -1 until we get the origin, and then it's a linear line with a slope of +1 onward to positive infinity. All right, now what becomes very, very useful is to identify what is the relationship between the basic function and the transform function. And I think it is important to write in h and k right away. And if I did transform f of x equals the absolute value of x, what I would have, and I'm going to write that as g of x as the transform function, what that would look like is function f evaluated at x minus h and then plus k. Now, what's very, very important is the statement, or the expression, I should say, inside the absolute value is representing the x minus h piece. And then the value outside, in this case, positive 3, is representing the k piece, or the k parameter, I'll often call it. So what that means is that our new function, to transform function g of x, and I'm just going to write g of x up there because that is how I'm identifying it, is going to be equal to function f evaluated at x minus 4 plus 3. Now, that makes it, I hope, a lot clearer that in this question, h is positive 4 and k is positive 3. Now, identifying the parameters is half the battle. Once you know the values of h and k, and later on a and b as well, what we can do is generate the concept, or a mapping, or we use a few different techniques for this, but I think at least to begin with, we should try to kind of hit all three. We are going to describe what these do to our graph. And if h is equal to 4, we have a horizontal translation 4 to the right. If k is equal to 3, I have a vertical translation 3 up. Now, this is guiding us as to how to draw g of x based on what f of x looks like. So in a mapping, I could take any point on the original function, which is g of x. Sorry here, I just kind of messed this up. I identified f of x as the standard absolute value function, so that is f of x. And when I get that point on g of x, I'm going to add 4 to the x's, and I'm going to add 3 to the y's. Right? This is my horizontal translation 4 to the right, and then this is my vertical translation 3 up. Sorry about the crisscrossing arrows there. So what that means in the context of our graph is we can grab a couple points, and I'll just write them down here. They're relatively easy to generate. This would be at 0, 0. Up here, we have 1, 1, and then back here we have -1, 1. Now, I would highly recommend that depending on the complexity of the graph, grab more points. If you need to use 2, 2, and -2, 2, and 3, 3, and so on, that's fine. With, maybe unique or direction changing graphs, I would always recommend you grab the vertex, which in this case is at the origin 0, 0, because that is a pretty important point. It's a pivotal point where the absolute value function actually changes pieces, if we want to use that terminology. All right, now keep in mind that down here, and it kind of got off the smartboard, sorry about that, that I am going to add 4 to all the x's and add 3's to all the y's. So I'm going to draw that new function in blue, and what's going to happen is that 0, 0 is going to turn into 4, 3, and I'll put that point down here so it's out of the way. 1, 1 is going to turn into the point 5, 4, again, adding 4 to the x and adding 3 to the y. And then -1, 1 is going to turn into, I'll put it down here, but that will be 3, 4. Now, again, translations, which is what we're working with right now, do not change the shape of the graph. So knowing the pivotal point or the direction changing point and the other two means I can connect those via a line. And that blue graph is y equals the absolute value of x minus 4 plus 3. Now, as you're working through this, I would highly recommend you check these on your calculator when possible, and it is more than possible for this question. If you want to see what this looks like on your calculator, you would have to put in y is equal to abs is the absolute value function. Then we have x minus 4. You need to close that bracket and then add 3 outside. This will give you the precise graph, and it is a good idea, I think, to graph that on your calculator to, at the very least, confirm your answer and kind of, make sure you're on the right track.